Welcome to lesson 7.6. Today we're going to talk about solving systems of linear inequalities. We have worked on graphing linear inequalities before, just never two at a time. So one thing I want to point out is that a system of linear inequalities is one that has two of them. So for example, in this sentence, we see this inequality 1 and then inequality 2. It's just good to notice that there's two of them. When we put them together, we are going to look for the overlap. Okay, so let's look at our first example down here. Example A. I'm going to highlight my first inequality in blue, the second one in green. Let's go ahead and graph these. Even though it's already on the screen, I'm going to use the pen. So y is greater than negative x minus 2. That means a y-intercept at negative 2. And a slope of negative 1. That means down 1, right 1, down 1, right 1. Keep doing that same pattern. Because it's a greater than sign, we're going to do a dashed line. So you can see that this is not totally a solid line. Because it's greater than, we're going to shade up. We're going to get to that in just a second. Let's look at shading our graph in our green line. That one has a y-intercept of positive 6. So put that green dot there. The slope is 3. I could go up 3 over 1 to there. That would be at the point 1,9. Or I could go down 3, left 1. I could do that again. And I could go all the way down the line. That one has a less than or equal to, so I'm going to draw a solid line. Now let's look at why I shaded where I did. The first inequality says y is greater, so that means to shade above. Let's go back and let's do that in blue. That means I'm going to shade above. We're not going to worry about testing, just think about shading up. The green inequality has a less than. We're going to shade down. Down would be towards the negative, so that would be on this side. Do you see where our shading overlaps, where the blue and green overlap? That would be inside this whole area. So we're going to darken that whole area. That is the answer to this inequality, or to this system of inequalities. Let's look at the next example. Example B. Y is less than x minus 4. I'm going to go ahead and highlight that one in blue. The second one I'm going to highlight in green. Okay, let's do the blue one first. Y is less than x minus 4. That means a y-intercept at negative 4. Sorry, I'm just trying to get my pen to work. There we go. -4. And a slope of 1. Up 1, right 1. Hopefully you can see why we're going up 1, right 1. And it says less than, so that's just going to be a dotted line. Now let's look at the shading for that one while we're here. The shading for our blue line, it says y is less than, so we want to think about shading below. Now let's look at our green line. Y is greater than or equal to -x plus 3. Plus 3 means a y-intercept at 3, +3, and -x means -1, so down 1, right 1. But that says greater than or equal to, so we want a solid line. To shade, y is greater, think about shading above or shading up. Okay, do you see the region where our shading overlaps? That is the answer to that system of inequalities. So we find where the shading overlaps, we darken it for your final answer. There's a few examples on here about a system of 3 inequalities. I'm going to go through these quickly. I'm not as concerned about you to being able to graph 3 of them, but it's still good to know that you can do it. This first inequality, it's highlighted in blue. Y is greater than or equal to -1. That would be this solid line right here. The second one that's highlighted in green, x is greater than -2. That would be this up and down line right here. And the third one, we have actually solved for y. Y is less than or equal to -1/2 x plus 2. That would be this line right here. Now the shading where everything overlaps is going to be this area, this triangle right in the middle. If you ever have 3 inequalities, they're usually going to overlap to form some sort of a shape. You can see the same example for example B, or letter B. The shading overlaps to form this triangle. The third example looks something like this. Ignore the line that I scribbled out. The overlap shading would be this big triangle right here. So that is the solution area. All points in that triangle are a solution. So make sure you get those examples written down, but most importantly to review, make sure you can do these 2 examples that we did under example 1. Shading that solution area where 2 inequalities overlap. Thank you for listening.